Hello IPX, we are here at PCIM 2024, the magical world of power. This is our first video for PCIM and we're here talking to Rupert from a UK startup called QPT, and we're going to talk about converters, particularly GaN converters, and he's going to tell us all about what a converter does in the world of power, why you choose GaN, and then of course why you choose QPT. So Rupert, tell us about your converter and where it goes and what it does.
So, half of all electricity in the world is used in electric motors, and that is going to get more and more as we get electric vehicles, heat pumps, the electrification of everything. To make those motors turn, you need some electronics. You need something called a drive, a controller, an inverter. And most of those today are shockingly inefficient.
Good word, shockingly. We like that, disruptive, shockingly.
So that means that a huge amount of energy is being wasted. It's wasted in the motor, it's wasted in the controller. What we've developed here at QPT is an incredibly efficient motor drive. Makes the motors work way better, burn less energy, release less heat, dissipate less CO2 into the atmosphere. So this is a really important technology.
Right, so what we're talking about here for our disruptors in our community is they know that in a system that uses electricity, or it's got any sort of power, they know when they put power in, there's an inefficiency, there's a loss. Naturally, when you put something through something, you're going to lose it. And what you're saying is you need the converter to turn it into the energy that you need in the system, and your converter is the most efficient at doing that. Now,
exactly.
And you've chosen GaN. Why did you choose GaN?
So GaN transistors are the next generation of power transistor. Historically, we've used silicon. That's moving over onto silicon carbide and compound semiconductors, wide band gap transistors. GaN, gallium nitride, is inherently a better transistor. Lower losses, less capacitance, faster switching, no body diode. The problem is, it's got a reputation for being difficult to work with. Most people can't make it work. And so conventional wisdom, GaN cannot do motor drives, can't deliver the oomph. We're proving that conventional wisdom wrong. We're delivering the oomph. So this drive, 7.5 kilowatts in something about the size of a hardback book, incredibly efficient, very little heat, and that's because of the beautiful thing of GaN transistors. We're actually on the Infineon booth, so I really should give a nice plug that Infineon have got some very gorgeous GaN transistors, and we love them as a partner. Thank you, Mr. Infineon, for letting us be on your booth.
Thank you, Mr. Infineon. Right, so shockingly, good pun with electricity, shockingly giving oomph into your power design.
And when you're talking about this kind of electricity, we're talking about hundreds and hundreds of volts, tens or hundreds of amps. There's a lot of shock to be had. So if you touch the wrong place in this design, it will hurt. Right.
So in your just last question, in your ideal scenario, our community's out there looking for disruptive technology. Where's the top 1, 2, 3 applications for this today?
For the QPT drive, it's industrial and consumer today. So motor drives, servos, air source heat pumps, machine tools, anything like that. In a year or so, we're going to be doing automotive, but we're not there yet.
Right, excellent. Well, thank you for that oomphy, electrifying introduction.
Thanks a lot.
To your technology. Enjoy the rest of your show.
All right, thanks a lot.
Thank you.
Hey, yo, where my engineers at?